Hello guys, welcome back to my channel Education and Masti. So today we are going to start with the part 2 of our chemistry chapter, Structure of Atom, and the topics that we are going to read are terms related to elements and isotopes, electronic configuration, all about valency and some ion and radicals. So terms related to elements means atomic number, mass number, atomic mass, and we will also know about isotopes, about electronic configuration, and all about valencies, valence shells and everything, and some ions and radicals. So now let's start this video with no waiting. So first let's see about atomic number. So what is actually atomic number? So atomic number is defined as the number of protons present in the nucleus of an atom of the element. That is called atomic number. And this is denoted by the letter Z. Since the atom is electrically neutral, the number of protons equals to the number of electrons. So here one thing we get to know that the number of protons equals to the number of electrons. Now let's move to the mass number. Before that, let me tell you what is this atomic number and mass number in an element. For example, I have taken this one element, that is X. Okay, that element is X. So the present number here will be the mass number and the present number here will be the atomic number. For example, let's take the example, or here we can write it like this also. Like I have taken here this one, sulfur I have taken. Okay, I have taken sulfur and I have written this 32 here and this 16 here. So what is it representing? This 32 is representing the mass number, and this down part is the 16 is representing atomic number, that is Z. It is noted by Z, so Z. So here we can clearly understand what is mass number and what is an atomic number. Now let's know about mass number. The sum of number of proton and neutrons, means it is the sum of proton and neutrons which is present in the nucleus of an atom of an element, is called mass number. It is denoted by the letter A. Now what is atomic mass? So the number of times an element is heavier than 1 by 12 parts of a mass of carbon atom is called atomic mass. So eagerly what it means, that the number of times an element is heavier than 1 by 12 parts of a mass of carbon. That is called the atomic mass. So the representation of an element with its atomic number and mass number is given here, as I have already told you. So atomic mass is basically the mass of an element, or whatever its actual mass is. It is 1 by 12 parts of the mass of a carbon atom. Now let's see isotopes. So atoms of same element with same atomic number but different mass number are called isotope. So which means that the atoms of same element with same atomic number. So atoms of same element with same atomic number but different mass number are called isotopes. So these isotopes differ in their neutrons. Most of the elements have more than 2 isotopes. Since isotopes have same atomic number, they have similar chemical properties, but they differ from one another in physical properties. So the number of neutrons equals to mass number minus atomic number. So what is actually isotopes formula to calculate the number of neutrons? So isotopes, basically we have to calculate the number of neutrons. So for calculating the number of neutrons, we have to take the mass number minus the atomic number. Means A minus Z we will do. Then we will get the number of neutrons. So I hope this is clear to you, the terms related to elements and isotopes. Now let's move to the next point, that is electronic configuration. Electronic configuration. So what is electronic configuration? The distribution of electrons in different shells revolving around the nucleus of an atom is called electronic configuration. So what is this electronic configuration? So it is the distribution of electrons in the different shells revolving around the nucleus of an atom. Nucleus, you know, it is at the center, and this is the shell, and the electrons which revolve around the nucleus in with this one shell is called electronic configuration. So basically now we understand what is electronic configuration, and in the previous video I have told you how we are arranging those. Okay, in all elements the shells are filled with the electrons using the formula 2n square. So using the formula 2n square we are doing that. So how we are doing that? Now let's see. So 2n square I have taken. Okay, 2n square. Then what I have did, I will take 2 into 1 square. Then I will get again 2 electrons. Then 2 into 2 square I will do. Then I will get 8 electrons. Then I will do 2 into 3 square. I will get then 18 electrons. Then I will do 2 into 4 square. I will get 32 electrons. So this is the maximum till where you can go. This is the end. After that you will not move on and move on. You can do that, but you can minimizing. You can do up to here only, up to 32. Okay. Then, so how the electrons are fixed, like I am taking this. You can see here in the figure here that how the electrons are being fixed or being put in the valence shells and on the other shells of the orbital diagrams. So we will know about this. Before that, let's understand more about this. So all the elements which have 8 electrons in the outermost shell, that is also known as valence shell, are stable and they attain electronic configuration of the nearest noble gas. This is called octet rule. So basically you need to understand what is this octet rule. Okay, so atoms of an element, okay, when atoms of an element loses, gains or shares electrons in a way that they have 8 electrons in their valence shell, to attain the configuration of the noble gases, that is what is octet rule. Like suppose if in the outer shell there are 8 electrons, 2 is also okay, but if there are 8 electrons in the outer shell, so that will be a stable configuration, means that element will attain a stable configuration, and basically it is of the elements like our noble gases, helium, then we have neon and argon. So here we can see out 8 are there, here also out 8 are there, and here 2 it is there. So basically we understand only for this noble gases they are stable, attaining stable configuration. But other elements can also take this electronic configuration as stable. They can make their electronic configuration stable. How? By sharing, losing or gaining electrons, so that they can attain 8 electrons in their valence shell. That's why with that only they can attain the noble gas configuration. So that is what called the octet rule. Other elements can do it by losing, sharing or gaining. Okay, other elements can do it by losing, sharing or gaining. Okay, have you understood about this? I hope you have understood. Now let's see some of the elements, valence shells and everything. So here we have electronic configuration of elements with atomic number 1 to 20. So here we can see the list of elements from 1 to 20. So first see what elements are given: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon and phosphorus. So these elements have been given here. So here we are having the atomic number according to the numbers 1 to 15. So what are the electrons present in each of the shells? So in this one, K element is termed as, you can term as 1, 2, 3, 4 also, but basically it is taken as K element electronic configuration shell. And here one more 5 we have, that are sulfur, chloride, argon, and we have one more, that is our potassium and calcium. So here we have this also. So now let's see what types means what electrons are present in how many. So one electron is present in this one, hydrogen. Then basically from number this lithium, from lithium it started to fill L1, that is the second one. Means you need to understand. Basically first after seeing this you need to see this, or after seeing this you need to see that. So understand here this one. So this is hydrogen. It has only one electron. Okay. Then here we have helium. Helium have 2. That is the stable one because it is a noble gas. Then we have lithium here, which has one at the this one L shell. This is L shell, and the electron which is having this one as M shell. Then we have beryllium, which has 4 electrons, and accordingly it goes on. Let's see the electronic configuration. Hydrogen has 1, then 2, then 2, 1 of lithium, then beryllium has 2, 2, then boron has 2, 3. Electronic configuration of carbon is 2, 4, then nitrogen 2, 5, oxygen 2, 6, 2, 7, 2, 8, 2, 8, 1, 2, 8, 2, 2, 8, 3, 2, 8, 4, 2, 8, 5, 2, 8, 6, 2, 8, 7, 2, 8, 8, 2, 8, 8, 1, 2, 8, 8, 2. So basically at the last, that is the valence shell, there should be 8 electrons present. Then only an element can be stable. So I hope you have understood that one. And basically in M shell, basically in the K shell there should be 2 electrons only present. Okay, then element 8 electrons can be there. But in the K shell, the starting shell, that is this shell, there should be only 2 electrons. I hope you have understood this. Now let's start with the next topic, that is all about valency. Valency. So in this topic we are going to see about valency and we are going to learn about valencies. So first is valence shell. So what is valence shell? As I've already told you, the outermost shell of an atom is known as the valence shell. So like I told you about the valency is the this one electronic configuration. Somehow like this it is there. Like this is one, here inside proton and neutron are there, and here electrons are moving around. So in this the last shell is this one only. So this is the valence shell of the electronic configuration or of the element. So every last shell or the last orbital diagram of the element is called valence shell. For example, if I draw here, let me draw one circle here. So here I am drawing a circle. So here in this, what I am saying, okay, one more circle I will draw inside here, like for proton, neutron. So here, like small circle also I can take any small circle. And here again I will take one more big circle like this of type. So this type of circle I will take one more big circle. Okay, let me arrange this. Okay. Now, here I will write the proton and neutrons. Okay, here I will write proton and neutron. Then what I will do, as I have already told you, in first shell 2 electrons are there. Then here take 4 electrons. Okay, take 4 electrons are there. So here the last shell is this shell. So this is called the valence shell. Okay, so the last shell of any one is called the valence shell. So what is the definition? The outermost shell of an atom is known as valence shell. Now what is the valence electron? The number of electrons present in the outermost shell is called the valence electrons. So if I ask you a question that how many valence electrons are present in this? Okay, how many valence electrons are present in this electronic configuration? Your answer should be that the number of valence electrons which are present in this are 4. So now you will tell how it is 4. So by the definition we get that the number of electrons which are present in the last shell, or that is the valence shell. So the number of electrons present in the valence shell is 4. 1, 2, 3, 4. So it will be 4. So now we understood valence shell and valence electrons. Now move to valencies. So what is valency? The number of electrons an element loses or gains or shares to attain stable configuration is called valency. The 3 things here what valency is doing. Either it is gaining some electrons or sharing some electrons, or what it is doing, it is losing some electrons. Okay, either gain, share or lose the electrons to make the configuration stable is called valence. So if an atom has its shell filled with electrons, it is said to have the stable configuration. If there are 8 electrons in the outermost orbital, then it is stable with octet configuration. So definitely we have learned about this octet configuration now only. So it tells that if the this one electronic configuration is stable, it has 8 electrons in the outermost or the valence shell. Okay, so 8 electrons it should be there. So how it brings 8 electrons? Either it gains. Otherwise, if it has 4 electrons, it loses 4 electrons, or it can gain also 4 electrons. 2 things can happen, and sharing and losing also. If there are 2 electrons, so will it gain 6 electrons, or it will be good for the element to lose 2 electrons. It will be easy for the element to lose 2 electrons, so it will lose like that only. For explanation, let us see here one more. Okay, let's take this diagram only. So I am taking this diagram. Let me erase it. Okay, now let's suppose this is of hydrogen. This one is hydrogen. Okay, so this is of hydrogen. Then I will be removing this one. Okay, deleted this one. So this is hydrogen. Hydrogen has only 1 electron. Okay, proton, neutron, only 1 electron it has. Okay, only 1 electron it has. So will it gain to 1 electron, or it will be easy for hydrogen to lose. So gaining is difficult. Okay, gaining is difficult. So losing is easy. So it will lose one electron. So it will be stable. Now if I tell you about lithium. Okay, lithium has like that only. Let me draw. It has one small circle here. Then it has one here circle. Then it has one outsider circle. Okay. So let me arrange these circles first. Okay. Okay. So it is little bit. Okay. Let it be. So proton neutrons are there here. Proton neutrons are present. So let us see. So in the inside shell it has 2 electrons. Okay. In the inside shell it has 2 electrons. As you can see, it has 2 electrons. Here one and here one. Okay. And the outside shell it has 1 electron. So will it lose 1 electron or it will gain 7 electrons? For stable configuration it needs 7 electrons. So will it lose 1 electron or gain? It will lose definitely. So losing and gaining here we can understand. And if there are suppose 1, 2, 3, 4, 5, 6, 7 electrons. So will it lose 7 electrons or gain 1 electron? It will definitely gain 1 electron. So then it will become stable. Like that only we have to understand this thing. Now let's see this one, positive and negative valency. So during chemical reaction, if an element loses an electron to become stable, it gets a positive charge and this element is said to have electropositive valency. So the element which have positive charges or positive valency is called electropositive valency. So how an element can get positive valency? If it loses. If an element loses any electron, then it gets positive valency. And then opposite happens, if an element gains any electrons, then it becomes negative. Okay, so it becomes electronegative valency. So like sodium has atomic number 11. Okay, its electronic configuration is 281. It will lose the outermost electrons becoming positively charged. Yes. So it will lose 1 electron so that at the last shell it has 8 electrons. Like that only. So now you can understand by this case study here we can see 2, 8, 1, 11 electrons and then here 10 electrons because it has lost 1 electron. Therefore it will get the valency of +1. In case of elements like chlorine, it will gain 1 electron to become stable configuration. Okay, because it has 2, 8, 7. So will it lose 7 electrons or gain 1 electron? Gaining here will be easier. So it will gain 1 valency, and while gaining the valency, it will become negatively charged and it will have -1 valency. So depending on whether the elements have lost or gained 1, 2, 3 electrons, the elements are said to have positive or negative valencies called monovalent valencies, divalent valencies and trivalent valencies. So elements like helium, neon, etc. have valency equal to 0. Some elements like iron, copper, etc. exhibit multiple valencies. Okay, iron and copper it exhibits multiple valency. Like iron has 2, 3 valency. So 2, 3 what? Ferrous has valency of 2 plus and ferric has valency of 3 plus or +3, anything. Okay, and copper has cuprous plus 1 and it has one cupric which is +2. Okay, it is +1, it is +2. So I hope you have understood this one. And do you know the reason behind variable valency? So you should know the reason behind variable valency. Let me tell you the reason behind variable valency. So why do we have this variable valency? I think many of you don't know what is first variable valency. So first let's know what is this variable valency. So variable valency is that certain elements exhibit more than one valency. That is, they exhibit multiple valencies. Okay. So the elements that exhibit variable valency or multiple valency are called variable valency holders. So now here for example, as I have already said here, example iron and copper are example. Iron and copper are examples of the multiple valency. So but the reason is why they exhibit, why exhibition is there, why they exhibit more than one valency. So they exhibit more than one valency because sometimes what happens, basically we know that when hydrogen, let me take hydrogen. So hydrogen loses one electron, then it gains. So it loses the electrons. Basically the elements who do not have variable valency, they lose electron from the valence shell, that is the last shell. Okay, so basically all the elements lose their electrons from the valence shell, lose electrons from the valence shell. But what happens now? But in case of this multiple valency, but in case of multiple valency or variable valency, what happens? In case of variable valency, the elements or this one, the elements loses the electrons from the penultimate shell, that is the second last shell. They lose electrons from the penultimate shell. So therefore they exhibit variable valency, because they sometimes they lose electrons from the this one penultimate shell, that is the second last shell. The second last shell is called the penultimate shell. So that is the reason why they exhibit variable valency, because sometimes from penultimate shell and sometimes from valence shell they do this. So therefore they exhibit variable valency. So this stepwise I have done this. I hope you will understand this. So now we will talk about some ion and radicals. Already the video has been very much lengthy. Let us finish this video fast. Some ion and radicals. So here we will be seeing some common radicals and some monovalent and divalent valent or ions, and some elements that exhibit variable valency. So here overall view we will be seeing of the examples type we will be seeing. So let's see some radicals here. So here we have some radicals: sulfate, sulfide, nitrate, nitrite, carbonate, phosphate, ammonium. Their valencies and their formulas have been displayed here. Then we have some symbols and names of the cations and anions. Monovalent ions we have hydrogen, sodium, lithium, potassium, fluorine. Here cation, and here fluorine, anion and chlorine. Here also in divalent ions, cation, that is the positive valency. Okay, this one is cation is here positive and anion is here negative. Then element showing variable valencies. So element, here we have copper, lead, iron, mercury, and valency 1, 2, 3, 1, 2, 3. Like this we have valencies here. Their ion and the name of the ions have been displayed here. So here you can take a screenshot so that you can understand it better. Here you have a view of screenshot. So I hope you have understood this chapter. So I guess it is understood to you. Now one more part I will be bringing. So basically that part will be related to radioactivity. So this radioactivity part will be coming under this structure of atom only. So you might be thinking radioactivity is different, but it joins some parts of this. So therefore I will be bringing that video also, and that we will be knowing about radioactivity and more things. And stay tuned with my channel to know about what I will be saying. So thanks for watching this video. Subscribe, like and share my channel. I know it is after 1 to 2 weeks, so I am sorry for that, but please share this video with all your friends, like and share. Thanks for watching.